All right. Well, good morning, good evening, wherever you are joining from. Welcome to this joint webinar on the latest die attach developments presented by Henkel and Caplinq. So my name is Ruud De Wit. I'm within Henkel 30 years or so, 20 years in let's say semiconductor support, new business development in Europe, and I'm hosting this webinar together with Christopher Perabo from Caplinq. He will introduce himself and Caplinq soon. So you may, for those people who are wondering why is this joint venture here on the screen. So basically, in 2019 we have asked Caplinq to support us on the semiconductor business in Europe to start with, and now also in the Americas. Henkel is investing a lot in Asia because there is the main business and also the main growth. But to make sure that we continue to support our customers here in the West, well, we are very happy with the specialized partner Caplinq. So Chris, I would say let's say please go ahead with the first part, introduce yourself, and then I will come back after 25 minutes on the other two topics.
Hi, thanks Ruud, thank you for that, and thanks for the introduction. I'd like to start off by giving a bit of a background information about Caplinq and also a little bit about myself personally. So Caplinq is a customer-focused specialty chemical supplier, and we're not a traditional distributor. Unlike a traditional distributor, we lead customer material qualifications, and we do that with highly technically trained sales engineers and hands-on applications engineers also. We have a focus on semiconductor specialty materials, and including die attach, of which this webinar for die attach is an example. Also for encapsulants and underfills, which just might be our next webinar. For solder products, but we also sell and support epoxy molding compounds, mold maintenance materials, and thermal interface materials. We provide local support and global coordination. That means that in the Americas, in Europe, and in Asia, we have local technical support engineers in each of the regions. But globally, we coordinate application notes, troubleshooting guides, and we put all of that information online, including product specifications, technical data sheets, safety data sheets, and the data packages that you'll see throughout this presentation. Also in this presentation, you'll notice that there's a lot of links to all the products, and each of these will take you to the appropriate product page, which shows all of the products that will be discussed through this webinar. So I'm going to start off the die attach paste development presentation talking about the die attach pastes themselves. The way that this webinar has been set up, or the way that I will be presenting, you'll see that there's going to be a lot of words on the slides. Don't worry too much about trying to read all the words. I hope that I can just engage with you and keep your attention, because all of the content of this webinar will be available after the webinar that you can be able to download. And it's really meant to be reference material for afterwards so that you can review some of the information that you may have missed during this presentation. You'll also see that there's some some basic die attach material in here, which may not be applicable to everyone. I'm going to go through that information pretty quickly to get through the meat of the material, but I just want to make sure that it's covered so that you can use it for reference material later on. Also, if you have any questions, I will just say, please put them in the question box, and towards the end of the webinar, Ruud and I will get to them, and then we'll answer them all at the end of the webinar. So let's get started. The basics of die attach. What is die attach? Die attach in a nutshell is basically the material that attaches the die to the substrate. And in doing so, it provides the package, the semiconductor package, with an acceptable amount of reliability. And it's also there to absorb the package stress depending on the package that you're making. Die attach adhesives can broadly be put into three main categories. Pastes, of which I'm going to be presenting today, conductive and non-conductive, also soft solder paste, and die attach films, conductive and non-conductive, and Ruud will be covering that later on. The die being attached to the substrate basically has three configurations. You could have the die mounted onto a lead frame, or the die mounted onto a laminate, or a die mounted onto another die. Comparing a lead frame to a laminate, the lead frame is an older technology, but it's also a technology that's used in a lot of applications that are less advanced, if you want to say it that way. What that means basically is that there's one layer to which the die is being attached to, as opposed to a laminate package, which is made up of multiple layers, and all of these layers allow for much more advanced packaging. So whereas the die is going to be attached to a metal lead frame in the lead frame packaging, in laminate packaging it's going to be attached to the top layer of the laminate. Die attach pastes, the basic chemistry of the die attach paste, only has the purpose of what the die attach chemistry as a base material provides. But the magic is really in the fillers. And the fillers allow the material to take on other properties and have other characteristics that the base die attach material can provide. The two categories of fillers are conductive, electrically conductive, and non-conductive. When we talk about electrically conductive fillers, we talk about silver, which is primarily what's used, but there are also gold, also copper and silver plated copper, as well as nickel in some die attach materials. On the conductive side, the most traditional material that's used is silica. Silica being non-conductive, but it's also quite abrasive, or it can be abrasive. So in applications that need lower stress, or for applications that might be die stacking, Teflon is often used in these cases. When I say non-conductive, I mean non-electrically conductive. Other fillers such as alumina, boron, and aluminum nitride allow the material to be thermally conductive while still maintaining electrical insulation. The main material properties when you're talking about a die attach material can be split into two broad categories. The first category is the reliability. And there we're talking about glass transition temperature, coefficient of thermal expansion, CTE, the modulus of the material, and the die shear strength. If we take a look at common materials such as the silicon die itself, which with a CTE of 3, or ceramic or the FR4 and a laminate substrate, or even lead frames that might have a CTE of 17 or 18. Oftentimes engineers want to have the lowest possible CTE for their die attach, when in fact what they should be looking for is the CTE that best matches the die and the substrate to which it's being attached. If we take a look at other material properties, they're geared more towards the processability, being able to use that paste in their package. The two main properties, namely thixotropic index and viscosity. Thixotropic index is the higher the number, the more that the material will keep its shape after it's being dispensed out of the syringe dispense. Viscosity, on the other hand, is about the fluidity of the material. It's how well does the material flow. If you take a layman's example of peanut butter, and it might have a viscosity of 250,000 centipoise, and water, which has roughly a viscosity of 1 centipoise, then a silver-filled epoxy die attach material might have a viscosity between 8,000 and 140,000 centipoise. The base chemistry of the material that's used is also very important, and the materials that we have cover a wide range of base chemistries. Epoxies have been used traditionally and historically because they have a very good adhesion to a wide amount of substrates, and also because they have very good thermal resistance up to 150 degrees Celsius, and in some cases higher. But other chemistries exist. I won't talk about silicones right now, but I will later on. But acrylates, for example, might allow the material to cure much more quickly with UV light, but they do have some oxygen inhibition. Bismuthimides, on the other hand, they have very good hydrophobicity, which means that they repel the water, which makes up for a much lower water absorption. However, bismuthimides have low cohesion strength, which means that they don't have much adhesion to itself. This is where the hybrids come in. Hybrids mix and match some of these chemistries together in order to make the strong points of the chemistry stronger, while making the weaker points of the chemistry less important. Die attach is a chemistry, and suffice it to say that chemistry in Europe needs to be REACH and RoHS compliant. Suffice it to say that all the materials that I'll be talking about during this presentation comply with REACH and SVHC regulations. The basic die attach process flow means that you have to take the paste and you have to put it on top of the substrate. And then you pick and place the material on top of the die attach, then you cure that die in place, and then you go on with your packaging of the material. The basic application methods for a liquid has traditionally been a single needle dispense. Single needle is a positive displacement volumetric uniform dispensing method, and it's been used for a long time and it's good. The problem is that it can be pretty slow. And for that reason, people are investigating other ways to dispense a liquid material to make the throughput higher and to be able to print it more quickly. This includes showerhead, transfer printing, or stencil printing. But the one that I want to spend a bit of time on, if you can see this video a little bit, is jet dispensing. Jet dispensing is the newest way of dispensing die attach adhesives. It allows about 4 times the speed of a traditional single needle dispense. And as you can see in this video, it can be done very quickly. And it never comes into contact with the substrate which you're applying the die attach material for. Not all of the materials can be used with the jet dispensing material, but Henkel does offer die attach materials that can be used with a jet dispense. You'll see later on when we talk about material considerations that if you're using a jet dispense, then we'll steer your decision for a die attach material in one direction or another. Getting to the meat of the matter, if you take a look at what the lead die attach considerations are, this is what we do. This is what Caplinq does with our sales engineers and with our applications engineers. We really need to understand what it is that you're bonding to be able to make the right product recommendation for you. So the first thing that we're going to be asking about is about the die, the size and the type of the die. Traditionally, silicon has always been used, but with new semiconductor technologies, such as silicon carbide, gallium nitride, and so on, they have different properties, and then also that necessitates a different die attach material. Silicon carbide, for example, can generate a whole lot of heat, and so you might be looking for a thermal conductive material to be able to dissipate that heat through the die attach material itself. Also, the size of the die is very important also. As I mentioned at the beginning, the main purpose of the die attach material is to absorb the stress into the package. The larger the die, the more the stress. So in order to make the right material choice for one die attach material that might be good for a small die, may no longer be suitable for a larger die. Then when you're talking about the die may have a metallization level on it. And that metallization layer then is ultimately the surface to which the die attach material has to adhere. Similarly, the substrate that it needs to adhere to is also going to be an important consideration to make sure that the chemistry and the die attach material selected has good high die temperature die shear strength to those substrates. Gold, silver, nickel, palladium, gold, and so forth. Bond line thickness, the trend in these packages is to go thinner and thinner and thinner for miniaturization. But as you go thinner, that leaves less die attach material to take up the stress within the package. So ideally you would say, well, give me the highest bond line thickness that I can, but as you're trying to shrink that down, you're going to go for a thinner bond line, which means that you might want to consider materials that have a lower stress or maybe a lower modulus for those applications. Then you're looking at conductive, non-conductive. What are the thermal and electrical requirements that are required for your package type? Does it need to have thermal conductivity? And if so, how much? And then reliability. So for plastic packages, MSL reliability is an important consideration, but even for other packages, it might need to meet a mil spec or a NASA outgassing or maybe an ACQ100 specification. There's nothing new about hermetic packaging. In fact, it's the oldest packaging technology of semiconductors. And it was really the whole technology of replacing hermetic packaging with plastics that changed this entire industry. But the reason I want to bring this up is because in Europe and in the Americas, we have low volume, high mix applications. And these are also the applications that are for our customers, for you, our customers, doing automotive, aerospace, or military applications. So I don't want to spend too much time on it, except to say that the technology for these materials is really in the assembly films that you see down here. And also for the silver glass is the die attach paste that is used inside of hermetic packages. The QMI2569 and the QMI355R, they're older than I am, almost, but these materials have been used reliably for hermetic packages for years. So the QMI2569 is the easiest for processing, whereas the 355R is used for processing temperatures lower, and in these cases, lower means 300 degrees Celsius. Not to be missed for military specs and for hermetic packages are NASA and MIL spec approved products. On the left here, you'll see a number of NASA approved products for low outgassing, and these ones here are split between conductive materials and non-conductive materials. And you'll see this product here that's in the list. This is one of the new products that I'll be talking about. The QMI529HT does also meet NASA outgassing. On the right-hand side are the MIL specs that it also meets. So these materials here all have packages that are available that meet MIL specs, including the 529HT. Now I want to start getting into specific applications. So if we talk about applications, the first one I'll talk about is Smartcard. There's nothing new about the Smartcard application, and certainly the two products that I'll mention here, the 2030SC and the 2033SC, those are the workhorses of the products for Smartcard. And they've been used for many years and has grown with the Smartcard industry. But the new products that I would like to talk about are the 2030 SCR and the 2035 SCR. These are packages, these are products that are based on the original success of the materials, the 2033SC and the 2030SC material, the original workhorse materials, except, and importantly, that they are very green. What I mean by very green is that they are SVHC. They don't have any SVHCs, and they are CMR DCHP free formulations. So it's the same base reliability with improved environmental considerations. So even though you may not be using them now, if these products should ever not be able to be used for SVHC, these Henkel die attach materials are future-proofed with this reliability, with this environmental improvement. At the same time, the material itself has also been improved, and that means that it has an improved work life. It's also more compatible with the UV encapsulants, which is the primary way of encapsulating Smartcard packages. Turning the attention now to MEMS, these can broadly be put into two categories, optical sensors and 3D sensors. What is important about products for these applications is that oftentimes they require low temperature cure. And the materials that are used for these MEMS packages might be LCP, liquid crystal polymer, and other metal finishes that aren't necessarily found in other semiconductor packages. So the materials that are used for these packages are specifically designed to have the adhesion to these material types. Similarly, because they are sensors, they need to have a low outgassing so that it doesn't distort the sensor's main purpose. And likewise, some of these materials that are being used may be sensitive to higher temperatures, so they have to be cured at lower temperatures that laminates and Leadframe materials would be able to take. So if you take a look at traditional materials that have been used, this is the QMI536NB. The NB stands for non-bleed, and this is a Teflon material that's been used for a long time for these package types. 538NB is a similar technology, but is suitable for even larger dies because it has a lower modulus than the 536NB. The 4015 is a material that's been designed specifically to cure below 100 degrees Celsius. And the silver-filled silicones of 4000 and 4001 have been running in high volume manufacturing and automotive applications. And the one material that I want to spend a little bit more time on is the 8142B. When you think of silicones, you don't typically think of low outgassing, but this material is actually a relatively low outgassing for a silicone for MEMS applications. The other thing that's very important about this material is that it has a very low modulus. You can see here down below 0 degrees Celsius and out to 300 degrees Celsius. It's an ultra low modulus, so very low stress on the part, and throughout the entire application temperature, operating temperature of the device. For automotive applications, there's automotive and then there's automotive. If you're talking about putting a DVD in the back of the car with your kids, or some instrumentation, or for comfort and control, yes, those are automotive applications. But when you talk about safety and control, powertrain and chassis applications, you have to make sure that the automobiles continue to operate under very extreme conditions. So for these, that's where the automotive grade requirements come in. And the requirements go from 3 to 2 to 1 to 0, with 0 being the most stringent. Most stringent means a temperature cycling of -55 to 150 C for 2000 cycles or the equivalent. If you take a look at the materials that we have available for the grade 0, you'll notice that these are all lead frame type applications. It's no surprise then also that these will also give you the highest level of MSL reliability. There's two products in particular that I will highlight after this slide. There are materials, however, that if your requirements are only for a grade 1 automotive application, then there are other materials that may be available even for package types that aren't a lead frame, like BT or a laminate substrate. So the QMI529HT-LV is actually a silver-filled die attach material. The HT stands for high thermal conductivity. And the way that you get this high thermal conductivity is that you stuff it very full with silver, which gives it very good thermal conductivity. The problem, of course, is that you have a hard time dispensing it. Everything I've been talking about has been about dispensing die attach pastes. So what this material is, unlike its predecessor, is an LV version. The LV means low viscosity, which allows it to have a thermal conductivity still of 8 watts per meter Kelvin, while still being able to be used and treated and dispensed like a die attach paste. Again, the links to the materials that you see here, if you click on these links, it'll take you to the product page itself and even the entire engineering data packages that are available. The 8920TC, on the other hand, is a thermally conductive, but it's an electrically insulating material. Thermal conductivity is always relative, and if you look at this thermal conductivity, it has a thermal conductivity of 3 watts per meter Kelvin, which is relatively high for an electrically insulating die attach materials. For automotive applications, it has been used for grade 0 reliability and applications such as vertical cavity lasers and LED attach in sensors. The other material is the automotive grade die attach, conductive die attach for QFN packages up to 7 by 7 millimeters. This material here has very high die shear strength. So compared to previous generations of our own materials, as well as competitive materials, this is really our lead push product for conductive die attach for QFN packages, especially large packages. So by having a high die shear strength, low moisture absorption, and significantly lower stress and low warpage, it makes it more suitable for larger packages and for even higher reliability of existing packages. Just because it's new doesn't mean that it's the best one for your application. As I've said throughout this presentation, there's many considerations that you have to take into account when you're making your die attach selection. If you take a look, these materials here that I've put together for you are the high volume runners for global applications for lead frame. They're split generally between conductive applications and non-conductive applications. And then each of the package types, whether it's discrete dip LED or SOIC, TSSOP, TSOP, QFP, and QFN. And the links to all of these products are available by clicking through here. And here the ones are the new products that I've highlighted already are also highlighted in this table. For laminates and for sensor applications, same thing here. Just because it's new doesn't mean it's the best. Maybe your bond line thickness is different. Maybe you need thermal conductivity. Maybe you don't. Maybe you need it big. Maybe you need it small. These are all questions that we need to answer before we can make a product recommendation for you. But similarly, conductive and non-conductive packages, these are the global lead runners for these package types. And for die attach, you'll notice that there's no new die stacking material that's listed here. And that's because the trend for die stacking has traditionally, or is now moving towards films, which Ruud will talk about in just a moment. So that's most of what I have to share with you today on die attach pastes. I would like to encourage you to contact us if there's anything that we can help you with. And with that, I'm going to pass it over to Ruud to pick it up from here. Thank you.
All right, Chris. Okay. Let's see if I can get the screen. All right, Chris. Well, many thanks for a very precise overview. Again, also great efforts and a great job. Yeah, to the Caplinq team to absorb all that information in a very short time. So yeah, very well done. Okay, I will move on with yeah, let's say some other technologies, and let's say if you look at our investments in new materials, yeah, there is clearly a need for higher power. So higher power, higher thermal is important. Dies are getting smaller, or more heat dissipation. So basically, I will kick off with going over the sintering materials which are being introduced, and also end up with some die attach film updates. So basically, some history on the die attach side. I have personal history on this. About 20 years ago. In meantime, how time flies. Yeah, then we had the lead-free conversion on the printed circuit board level, right? And a lot of applications had to move to SEC type of alloys. But the semiconductor industry is still using lead because of the high melting point. And that's also exempt when it's fully encapsulated. But basically, that is valid until a lead-free drop-in replacement has been identified and qualified. And we are now 20 years later, and still there isn't a true drop-in replacement identified. But we keep on searching, of course, and developing and working with our customers to achieve this. So I will lead you through let's say this history and what is available today. So apart from lead-free, as I mentioned already, higher power density is another driver. Also the change in chip technology, moving to gallium arsenide, gallium nitride, silicon carbide running at higher temperatures. Then solder is getting marginal on reliability. And reliability, like Chris already mentioned, automotive, higher temperatures is also one of the key reasons to go to sintering, because let's say most solder joints cannot pass 1,000 cycles automotive. And then we indeed have also smaller packages with limited space for solder, fluxes, fillets, etc. And of course, the sustainability comes in as well. Customers and end users, especially in consumer electronics, but also now in new energy vehicles, like to offer true green solutions, so not having still some lead in the power semiconductors. So basically, what is then sintering versus the stacking adhesive? The stacking adhesives Chris already covered, like the QMI529HT, right? Now, basically, the big difference is you have the physical contact in case of the stacking. You can see that here on the picture on the left. So it's physical contact, while for sintering, let's say you really get the diffusion leading to a really metallic joint. So I think that's the key difference. And I think in the beginning, let's say there was pure sintering developed. Basically, dissolving ultrafine pillar particles into in a solvent. And then for power modules, that was then, let's say, assembled with force, 5 to 30, at that time certainly 30 megapascal, to suppress the volume shrinkage and the porosity. But okay, I think these has been tested in power IC, power semiconductors about 10 years ago, and then that porosity level, when you don't apply the pressure, you get this kind of porosity. And especially in lead frame based semiconductor applications, this was a nice path for moisture to penetrate during moisture sensitivity tests. And then, as you can see also here with a fluorescent agent, you get moisture into the joint and in the end delamination and failures. So pure silver sintering is not a solution for semiconductor applications requiring MSL performance. So that's why we developed the hybrid sintering materials. And here you can see nice the combination. So moving from the stacking resin-based and an open structure to a resin, resin-supported polymer-assisted hybrid system, which will fill the gaps. Basically, the first successful application for this technology was in RF system in package design front-end modules, where small dies, relatively small dies, need to be assembled in a system in package with components very close to the die. So basically, there was a need for lead-free for environmental reasons, high thermal, high electrical joints, and here, the silver hybrid sintering has been adopted quickly. So basically, there are much more options. Let's say also conductive films are used in this application, but especially when the high thermal need is there, then this so-called ABP 8068 TB was successfurly qualified and running now in high volume. I will also cover two other materials, further developments, TI and TD, to make it a little bit short. So, as I mentioned, TB is basically the high volume runner in Asia at many subcontractors, also at just power I see in discrete makers as well, more and more. But it got qualified in power low noise amplifiers, die sizes up to 2x2 on a silver and a PPF lead frame, and basically having about 100 watt-meter Kelvin thermal conductivity. And as you can see, a very controlled fillet. And I think one of the key things here as well is this works like a standard die attach, like a standard SR4, like the QMI2529 LV Chris talked about. And so there is no difference, no press. Sinters at 200 degrees, a little bit higher than maybe a die attach paste, but it's comparable. And in the end, it has a thermal conductivity package measured in package, comparable to soft solder. But okay, I think then this is for small die, successful, widely used. But then how about bigger dies? And of course, here we're talking, we're looking still for the holy grail. So I think you can imagine the bigger the die, the bigger the stresses are over the die from the center to the edge. And what happens here, you see some nice cross sections of the first gen material, TA, comparable to TB. Basically, it failed 500 cycles automotive on, in this case, a 3x3 millimeter die at the edges. And here you see the crack from the edges where the stress is the highest going inside. So basically, this is what we call silver fracture. It's a cohesive failure in the sinter joint. So This is, let's say, on the edges. But if you look in the middle, you see a very good sintering to both sides, and also a nice polymer assisted structure. So this is all about how to absorb the stress. And I think there were two approaches we went over. And one was going higher silver loading, higher density, as you can see here. That is the TI development. You see also the strength going up. And basically this was to prevent the fracture. And so this was one approach. And then if we do temperature cycling, we faced a different kind of failure mode in the die. So that is nice as an adhesive supplier saying, hey, we have a great joint, but basically it's of course a failure, and this is something customers cannot accept as well. So for certain applications, this is a very good material, but still this die crack, of course, is something we also need to solve. And here you can see some cross sections, only a small delamination at the edges after 1,000 cycles, within the typical spec of maximum 10%. But indeed, you see here the die crack in the center. Nevertheless, this material got qualified in certain applications, power applications, and especially showing very low and very stable RDS on after reliability testing. And that's the reason why it got qualified and starting in production. And for the rest, also here, same easy dispensing, just like a normal die attach, and typical work life of 24 hours. Basically the way of working of a standard die attach dispense process. To solve that die crack issue, we also went the other way around to increase the resin loading. In other words, less silver, so lower modulus. And I think this is our latest commercial material we launched. So basically then we compromise on the build conductivity, about 50 watt-meter Kelvin, but the modulus is going down a lot to about 8. And then if we do the MSL and temperature cycling tests on our internal test vehicle, then you see, let's say that material is passing up to 1,000 cycles on 3x3. Okay, it's still not the holy grail, but this is certainly good for expanding the application use. And also again, really designed by a die attach specialist, and easy to process. You see beautiful fillets, and this is what actually you don't see the difference between a sintering paste and a standard die attach paste. So here you can see the comparison. Let's say the TB high volume runner, higher, higher silver content and lower silver content versions, with the main difference basically, modulus, stress level, and also thermal conductivity. So please feel free to reach out to us if you would like to know more or try it out. Then a few words about the films. Films are very commonly used in Asia for high volume manufacturing. Main reasons are, let's say that, of course, with paste, you have a fillet, and especially where you have possibility of tilt. And then indeed, with a film, you can solve these issues. And why should you solve these issues? Basically, especially when the parts are getting smaller, dies are getting smaller, you get multi-die packages, dies close to each other, then there is no room for fillet. So basically with a conductive film in this case, or a non-conductive film, you can make fillet-free, very, very small assemblies. So that's what we call them also zero keep out zone. So very small, you can design dies very close to each other. And basically this was important when, for smartphones, especially consumer electronics, where more computing power and more ICs are getting into the same space. And I think here what is important, these die attach films, these are the conductive ones in this case, are supplied on a dicing foil. So basically, normally you would laminate your wafer on a dicing foil for dicing and pickup. Here, basically, you have already, you laminate the wafer on the silver layer, then you do the dicing, and then you pick up the die with the very controlled 15 micron silver layer die attach already on it, so no need for dispensing anymore. So here we have a nice product portfolio. Also here, depending on the die size, the larger die size means actually then softer materials, and basically, these are all proven materials, well established in the market. So many customers using it. Although in Europe, the consumption is limited. Because the series are smaller here. But nevertheless, if you see a need for technical reasons, we are more than happy to support you. I will leave some technical data sheets here in the file. But basically, CDF 500 series is the most reliable, and basically we have also a lower cost version. Which is based on silver-plated copper filler, and that is also suitable for laminates. So I think these are two good materials with relatively low minimum order quantities, also important here in Europe, and they are available. So here you can see the summary in this comparison table. Then the last few words about non-conductive die attach films. Actually a similar story. Limited consumption in Europe, or actually the same in the US. Apologies for that. Actually, Americas and Europe are having similar niche applications, low to medium volume, specialized applications. And let's say limited use of film so far, but it's getting more. The requests are coming in. We have a big product portfolio for this, for different applications, for stacking, for small die, for film over wire, where you can embed the wires. I would like to highlight two materials. This is a high modulus, high TG material for small die. Here you see die sizes of 0.3 by 0.5 or something, which is being attached by this die attach film. Very stiff and very reliable, and a big volume runner worldwide now. And then, here you see the technical data. And then we have another material which is more lower modulus for bigger die sizes. And both materials, we believe that these materials have opportunities here. Both are high volume runners, so also the minimum order quantities can be also acceptable for applications in Europe or Americas. Here we have the nice data comparison versus the famous competitor L, and for your reference, one is slightly one of our materials is slightly higher in modulus, the other one is lower. And so please feel free to reach out. So that was in a nutshell the new developments on when we talk about silver sintering and die attach films. So I think it's time for a Q&A session. We'll see if there are any questions.
Yes, we've got a question here, Ruud. I'll take this first one. Question is if we have any LCA data to emphasize how green are these new products versus the older ones. This is referencing specifically to the Smartcard materials. And yes, we have a data package that shows, of course, the SVHC and the environmentally green nature of these materials that we can share with you. So if you, I think Ruud will talk about how to share some of the support for our customers, but we can get back to you with the package data on some of these materials also.
Yeah.
I have another question
That's
here, Ruud, that is for you, I think. Is Henkel also working on sintering materials, which will sinter under pressure, like for in power modules? Okay,
well, thanks. Good question. Yeah, basically our focus as a special chemistry company, we like resins, right? And in the end, as I also showed during the presentation, we started also with pure silver sintering, so pure metal materials, and basically then we run into moisture sensitivity issues in semiconductor die attach applications. So basically we will continue with our aim is to have hybrid sintering materials, but to expand it to larger die sizes, and also to develop some materials for integrated power modules, working on low CTE DBC substrates, for instance. And yeah, from that perspective, I think we want to certainly focus on that. But the aim will always be pressureless. So we are not aiming for materials which needs 1 or 2 minutes clamping at 260 degrees. I hope that answers your question. And otherwise, please reach out in a separate email.
There's more questions that are coming in here, Ruud. This one here says, why doesn't Henkel list the MSL ratings of all of their products on their TDSs? I can pick this one up.
Oh, yes, please.
The MSL ratings are very package specific. So it's impossible for an adhesive manufacturer to actually give a MSL rating for their materials because we don't know which package it's going to be used in. So but what we do say is if all things are being equal, if the TG is higher, if the CTE is lower, and the modulus and the stress is lower, and there's less moisture absorption, then that product will have a better MSL performance than its counterpart. So what we do as a formulator is we look to reduce the amount of moisture absorption, reduce the amount of stress, and reduce the CTE in the material, and that in turn translates into higher MSL performance. But because the adhesives, the substrates are different, the materials are different, then we can't say for sure what the MSL is going to pass. All we can do is we can formulate for specific material properties and then have our customers test on their parts to see what that MSL performance gives to them. Okay. I hope that answers your question, Ruud. I have another question. This one is for you, I think. For hybrid silver sintering for the more silver type, is this applicable for pressureless bonding?
Yes. Yeah, so basically, when we talk about those 3 materials, if I understand the question right, so for those hybrid materials, these are all pressureless. So we don't see the need to apply pressure, and yeah, we will continue to go pressureless all the way. There are more questions, I see.
Yes, there's a lot more questions that keep coming in. So
good.
Just to remind you, if you do have questions, please put them into the field down below and we'll try to answer them. We'll continue with this for another 10 minutes is what we have scheduled.
No problem.
We'll answer your question. We will come back to you afterwards with the answers to these questions. So the next question is, concerning the die attach films with silver, how do you cure? Do you sinter them and with or without pressure? For the die attach films with silver.
Yeah, okay. Now maybe I confused, let's say, with the speed of my presentation. So actually I had one section, let's say, about sintering materials, and maybe I made the change very quickly to the films, which are non-sintering. So maybe I was not clear there. So basically the conductive, the silver filled conductive die attach films we showed are non-sintering. So they are basically silver stacking. And yeah, so we looked in the past at sintering films, But then indeed, yeah, the difficulty is that they become pretty brittle to handle by the high silver loading. And they also needed some pressure for, yeah, a second or some seconds to attach. Nevertheless, this may be yeah, something we are going to look into again, right? But that's still to be confirmed. But yeah, if I about conductive films, basically these are B-stage layers of silver in a resin. And when you do the die attach, you need a low force and 120, 130 degrees. Then you attach the joint, and then it goes into an oven and gets its standard oven cure. So no pressure during the cure.
All right, thanks for that.
That
there's a few questions here that are somewhat related here, Ruud. Thanking us for a presentation and asking for more information. And the question is, who do they reach out to? So they say, yes, we are Henkel Caplinq customers. Who should we be reaching out to for support and for questions for samples or support?
Yeah, right. Well, I can take this one. Well, of course, I think the best way is if you are a customer buying material from Caplinq, I would always start with Caplinq. So, yeah, you have probably noticed we exchange information a lot, expertise, we do sharing. We believe Caplinq is very capable to follow up. So, but if you have yeah, standard contacts dealings with Henkel, you can ask me or your other representatives you know within Henkel. So I would always start with your contacts and let's say the company who's supplying. And in case you have, yeah, there are also a lot of companies, of course, in Europe doing spec in work. So basically doing all the tests and product selection, qualification work, but the business is going to Asia. Well, then of course also if you have, yeah, depends on who you are already in contact with, can follow up. And otherwise, yeah, which company are you most, let's say, comfortable with to start with? But we will work closely together to give you a suitable answer.
Yeah, if I can add to that also, I mean, our contact details are going to be shared. You see where you can get to the best answers, and you're welcome to find us.
Mm-hmm.
I have another question here about does the TG of the material determine the maximum operating temperature of the device? I'll pick that one up. The TGs, I mean, typically for epoxy materials, the TG is normally, I won't say limiting the operating temperature, but the TG, the only thing that the TG really shows is when the material goes from that harder phase to the softer phase. And there's a number of properties that change at that time, one of them being the coefficient of thermal expansion. And it goes from a lower, your alpha 1 to your alpha 2 at your TG. Also, the modulus also goes from a higher modulus to a lower modulus, typically at the TG. That's really the only thing that the TG is definitely going to tell you. Otherwise, if you have a more rigid material, but the modulus ends up being lower above the TG, then that can often even compensate for those cases. So it's definitely not an indication. If silicones have TGs even less than 0 degrees Celsius and are used in applications above 300 degrees Celsius. So certainly not, TG is not the only defining factor for operating condition of your package. Another question for you, Ruud, and they just keep coming in. We'll pick a couple up more here and go. How do you measure the thermal conductivity of your materials? Go ahead, Ruud.
Yeah, okay.
Unless you want.
Well, basically, we do that with we do the bulk thermal conductivity measurements on the material itself. So these are, yeah, in the end, thicker parts, cured parts, and then we measure the bulk conductivity. So the difficulty is, of course, when you talk about the reality in practice, if you have a thin mold line like 10, 20, 30 micron, that's something we cannot do this type of measurement on, because these parts you cannot make reliably. So basically, then we do the in-package thermal resistance tests, like I have shown with the sintering material. So then you measure really the whole thermal resistance over the whole bond line, including the interfaces. So that is then more a practical way, and actually a better value than a bulk value.
Thanks for that. One more question here, and then I think we should wrap it up, Ruud. The question is about for small syringes, for small samples to be able to do evaluations. 1 or 2 syringes, is it possible to do a low minimum order quantity? I can pick that up, and you can fill me in for anything that you.
Yeah, please.
Certainly, the materials I attach products that I presented, those materials are the largest global runners of the materials that are used worldwide, which is why we selected them. So, I mean, even though there's hundreds of die attach materials that Henkel offers, not all of them are necessarily. It's best to figure out what is your best application that you're using, and then find the right material that matches that. And it's ideally in line with the materials that we have available. So for small minimum order quantities, for just a couple syringes to do some testing, we often have samples that are available, and the samples then we can make available in limited quantities in order to do some of the testing, especially if it's part of the global big runners of materials that we currently supply. Anything you'd like to add to that, Ruud?
Yeah, I'd like to add here that let's say if you look at Americas and let's say and the European customers being transferred to Caplinq now, on both sides of the ocean, these are more than 100 customers. They all have their products they buy, and if you now see that Caplinq is handling them, they have these materials, a lot of materials on order, and they are, let's say, buying MOQs, like 10 or 20 or 100 pieces even. And then the good thing is that with Caplinq involved, there is they are much more flexible to take out 1 or 2 syringes for sampling, for instance. But okay, that's also still not always possible. And then that's also why we have a European sample stock of items, let's say, of volume runners. So here we can support it. And I think in Americas we have a production site in California who can also, their volume runners, they can be supplied in 2-3 weeks time. So I think let's always look at it case by case, and please reach out to us.
Yeah, well, I think that's about all the time that we have for today, Ruud. I'd like to thank you for being my co-host on this meeting. I hope that our customers also appreciated the information that we were able to share, and also the technical expertise with which we are able to share this information. So please don't hesitate to reach out to us for questions and for technical support, because we want to make you successful also. Anything to add to that, Ruud?
No, again, also many thanks for your attention. And maybe things went fast a little bit, but that's part of webinars, I think. And I think it's important to show what we all know. And yeah, I think we are happy to plan more of those webinars, for instance, 1 every quarter on other topics. So thanks for your attention. Thanks, Chris, as well. Thanks, Eva, for organizing. And yeah, we look forward to any reactions, queries, and to support you.
I would even say if the audience is interested in another webinar, if something in particular, then let us know what you want to hear, and we'll be happy to put something together for you. If this has been useful for you, it might be useful for others as well too. So spread the word, and thank you very much.
Wonderful. Thanks a lot.
Thank you.
Have a good morning and good evening, and hope to talk to you next time.
Thank you.
Thank you.
Bye-bye.